Okay, so today we're going to cover Chapter 4, Section 1. Today we're going to be looking at rational functions and asymptotes. So the graph of a rational function, again, remember, rational is just, in other words, we're going to be looking at functions that are fractions. Now, we're going to be finding domain of these rational functions. And remember, whenever you find domain, you always start out by thinking, oh, it's all real numbers, except when it's a fraction or when there's a square root. So in this particular example, my domain in words would be all real numbers, except, and then we need to figure out what would make this undefined. X cannot equal 0. So the domain in words would be all real numbers except when x equals 0. And then if you had to write it in interval notation, remember that would be from negative infinity up to the 0, jump over the 0, we would union that, and then 0 to infinity. So this would be in words, and this would be the interval notation. So remember, for the domain, when they're rational functions, we're just looking to see what would make our denominator a 0. Now, this is actually, they look like boomerangs almost. This is the graph of our hyperbola, which we're going to be focusing on conics in this chapter, which is kind of nice for the juniors who may be taking the SAT, because they tend to have a lot of conics questions on it. Now that you guys are moving forward and the SAT, once it's digital, is all calculator, there's actually a button on your calculator that has all the conic equations once we get further into the conics. But for now, we're just going to be worrying about getting ordered pairs for this quiz on Friday from our calculator. In this particular picture, I've got a horizontal asymptote, which is right here. If you notice, my graphs here are skimming along the x-axis and the y-axis. So my vertical asymptote is actually the y-axis. And we're going to learn how to calculate these. So the vertical asymptote is the equation x equals 0, and the horizontal is y equals 0. So this would be a horizontal asymptote, and this would be the vertical. But we're going to learn how to calculate these. Now, over here on this right side, where we're seeing this limits, this is sort of showing how it ties into calculus. You're not responsible for anything that I just boxed in blue. But what this is reading, if you read the first one, the vertical asymptote, it's telling us that this function f of x is increasing without bound as x approaches 0 from the right. And then here, this is saying that f of x decreases without bound as x approaches 0 from the left. And again, this is just tying it into calculus. Over here for the horizontals, this one, again, is saying that f of x approaches 0 as x increases without bound. And then the bottom one, f of x approaches 0 as x decreases without bound. Again, you don't need to worry about limits yet. That's something you're going to cover in calculus. But just to show you that there's a reason why we learn all of these things. So we're going to be covering asymptotes. We're going to be calculating the vertical asymptote, the horizontal asymptote, and the slant asymptote. So what we're going to be doing when we find a vertical asymptote, and whenever I label my things in my notes, I'm going to label vertical asymptotes as VA and horizontal as HA, because we're going to be finding a lot of things when we go to graph these. So for the vertical asymptote, what you need to do is simplify the fraction first and then set the denominator equal to 0. And then that will be where your graph cannot cross. Your graph will never cross a vertical asymptote. It'll skim along it. For the horizontal asymptote, most of the time it will not cross that line. However, it can. There will be the occasion where your graph will cross a horizontal asymptote, but most of the time it's just going to skim along it. Now, this has 3 different rules that you're going to need to memorize. So n is going to be the degree of the numerator, and m is going to be the degree of the denominator. So in order to figure out what type or what the actual horizontal asymptote is, we're going to be looking at the degrees of our numerator and the degree of the denominator and then compare them. Remember, to find the degree, we're going to look at the largest exponent when it's in standard form. That will give us the degree of that polynomial. If it's a constant, remember, a constant has a degree of 0. So we have 3 different scenarios. When we look at the degrees, if the degree of the numerator, or the top of the fraction, is smaller, then your asymptote is going to be just y equals 0. It's really just the x-axis. So this is when the numerator is smaller than the bottom, than the denominator. When the numerator is larger, this is the second scenario, then there is no horizontal asymptote. So when the top is bigger, or your numerator is bigger, then there's no horizontal asymptote. And then if the 2 degrees are equal, then we're going to take the 2 leading coefficients and put them into a ratio or into a fraction. Now, for this last one here, it's going to apply to number 2. And if the numerator is 1 larger, the degree is 1 larger than the denominator, then there's no horizontal, but we have a slant asymptote, and we're going to find that by using long division. So it's only when the numerator is 1 larger than the denominator. And then what we're going to do is we're going to divide, and then we're going to ignore the remainder. So let me show you some examples here. So let's say my function was f of x is equal to x to the third minus 2x plus x squared minus 5 over x plus 1. Now remember, we need to put it in standard form first, or in order from the biggest exponent down to the smallest. So notice I need to just switch these 2. So the function I'm going to use is x cubed plus x squared minus 2x minus 5 over, or divided by, x plus 1. Now, tomorrow when we start graphing these and we enter them into our calculator, you're going to either need to learn how to enter something in as a fraction, or what you're going to need to do is surround the numerator with parentheses and the denominator, and then use the division. But I'm going to show you how to enter it as a fraction. But if you don't have that capability on your calculator, then you need to surround the numerator with a parenthesis, then hit the division, and then surround the denominator with a parenthesis. So, but for tonight's homework, you're going to show all this work. You're not using your calculator to calculate these asymptotes. So this is what we would do. Now, if we wanted to find the slant asymptote, what we would need to do is look at the degrees. Notice this numerator has a degree of 3, and this one has a degree of 1, because I can assume a 1. So the top is not 1 bigger. So this one actually, when the top is bigger, then we would just say that there's no horizontal asymptote. So for the horizontal, you're going to write none because the top has a bigger degree. For the vertical asymptote, what we do is we set the denominator equal to 0. We subtract 1, and we have a vertical asymptote at x equals -1. So that's how you would find the asymptotes. So let's just do some examples. Okay, so when you have a hole in your graph, what'll happen is you're going to have to simplify your function first, and the factor that you cross off, that is where your hole is going to be located. Your hole is going to be an ordered pair. To find the coordinates of the hole, you're going to set the factor you crossed out equal to 0, solve for x, and then plug it back into the function to get your y value. So what will happen is your graph will look something like this. So let's say this is your x and your y axis. And let's say we calculated the hole, and let's say there was a hole located at the order pair 2, 3. So when you go to graph it, you're going to put a hole here, or an open circle, and then let's just say the rest of the graph went on like this. So when you have to graph a hole, you're going to graph an open circle. But we're going to see this coming up. Okay. So for the first one, let's go through and let's first find all the horizontal asymptotes. And those are those 3 rules where we're going to look at the degrees. So let's do all the horizontals first. So for the horizontal, this numerator, this degree, it's a constant, it has a degree of 0. The degree of the the denominator is a 1. So when the top has a smaller degree, the horizontal asymptote is just going to be y equals 0. So when the top is smaller, the horizontal asymptote you're going to memorize is y equals 0. It's actually going to be the x-axis. Let's go to number 2. Let's do the horizontals, all 3 horizontals first. Then I'm going to go back and do the vertical. So for the next one, notice this numerator has a degree of 1, because these exponents here are assumed to be a 1. This one also has a degree of 1. When the degrees are the same, so same degree in both the numerator and the denominator, this is where we're going to use the leading coefficient. So we're going to take the leading coefficient of the numerator and then the leading coefficient of the denominator. And that'll give us our equation. So my horizontal asymptote for number 2 is going to be y equals 2/3 because I'm using the leading coefficient. You need to make sure it's in order from the biggest exponent down to the constant first. Try the next one. The degree of my numerator, this degree is a 2. This degree is a 1. The top is the bigger degree. So this tells me when the top is bigger, my horizontal asymptote is none. Now, it also said to find a slant asymptote if one occurs. This one has a slant because the top is 1 bigger than the denominator. So when it's only 1 bigger, then I have to do long division. So let's go ahead and do the slant right now because the other 2 did not have a slant. And it's only when the numerator degree is 1 larger. So I'm going to do long division. Remember, when you do long division, you need to hold the place for any missing terms. So the numerator did not have an x term, So I got to hold the place with a 0x, and then I'm dividing it by the denominator. So what are we going to multiply x by to make it x squared? We're going to multiply it by an x. I'm going to distribute the x to the x to the 2, switch the signs to opposite, and then add the column. This is gone. So negative 2x, bring down. What are we going to multiply x by to make it become negative 2x? I'm going to multiply it by a negative 2. So then distribute. Change the signs to opposite. Add the column. Now, I don't do anything with the remainder, so I don't need that. So the equation for my slant asymptote is the equation y equals just the quotient, what's on top of the division box. And it's an equation, so you put y equals x minus 2. So remember, for the vertical asymptotes, what we need to do is first simplify the fraction if you can. If you can't, all you do is set the denominator equal to 0. So for number 1, I can't simplify anything here. So for my vertical asymptote, all I'm going to do is take x minus 1, set it equal to 0, add 1, and my vertical asymptote is x equals 1. So for WebAssign, you would enter y equals 0, comma, x equals 1. So you're going to enter them as an equation, and you're going to separate them with a comma. For number 2, nothing can be simplified. So what I'm going to do is take the denominator and set it equal to 0. So 3x plus 2 equals 0. Subtract 2. 3x equals negative 2. Divide. And x equals negative 2/3. So your vertical, negative 2/3. Your horizontal was y equals positive 2/3. And no slant asymptote. So you don't have to write none if it doesn't have one, only list the ones that they have. For number 3, nothing can be simplified. So all you're going to do for the vertical asymptote is take the denominator, set it equal to 0, subtract 2, and x equals negative 2. Now, once we start using the calculator tomorrow, when you key these functions into your calculator and you look at that table to get the order pairs, whenever there's an asymptote, it's going to show the word error in the table of values. Different answers. So you would enter, you wouldn't write, I'm sorry, no, only 2 answers because the horizontal is none. So you would just put y equals x minus 2, comma, x equals negative 2. So if it's none, you don't write the word none. All right, so for the next one. Now, it also says to check for holes. So we're also going to check for holes. So let's go ahead. Let's do all the horizontals first. And then we'll go back and do all the verticals. Actually, we could do, let's just finish the whole problem. All right, so let's do number 1. We're going to find everything. So I'm going to do the horizontal first. So remember, for the horizontal asymptote, we have to look at the degrees. This numerator has a degree of 1. The denominator has a degree of 2. The top is smaller. So when the top is smaller, we know our horizontal is just y equals 0. Now let's do the vertical. So for the vertical asymptote, I can't simplify anything because remember, these are attached. So I can't cancel out any x's or anything. Nothing simplifies. So all I do is take that denominator, set it equal to 0, subtract 3x squared equals negative 1, divide, x squared equals negative 1/3. When I try to square root this, I'm going to get an imaginary solution. I'm going to get x is equal to positive and negative I over the square root of 3. As soon as you see you've got an imaginary, then you're going to say no vertical asymptote, so none. We do not want to graph an imaginary asymptote. So as soon as you see you were going to be dealing with an imaginary number, you can stop. You don't even have to worry about rationalizing that. Just say that there's none. So for this question, the only thing you would enter is y equals 0. Try number 2. This one did not have a slant asymptote because the numerator was not larger. Number 2, let's do the horizontal. So for the horizontal, again, you look at the degrees. This degree is 2. This degree is 2. These are the same. So when it's the same, we use the leading coefficients. So this is going to be y equals 2 over 1, which equals 2. So my horizontal asymptote is y equals 2. Now, for finding anything to simplify, I couldn't factor that denominator to x plus 1, x minus 1, but it doesn't give me anything that cancels, so I'm just going to leave it. So then now what I need to do to get my vertical, I'm going to go ahead and set my denominator equal to 0. Now, in order to get this, I'm actually going to get 2. In order to do this, I could either factor it or use the square root method. If you choose to use the square root method, remember when we square root this and use this square root method, I'm going to get both positive and negative 1. So I have 2 vertical asymptotes. I've got one at x equals 1 and x equals negative 1. So it actually has 2. The other way you could have solved it is factored it. X plus 1, x minus 1, and then set each of the factors equal to 0. Some of these denominators are going to be trinomials that you're going to have to factor. So you can have more than one vertical asymptote, or even in this case. All right, everybody good there? All right, number 3. So again, my degrees were the same. I don't even have to look for a slant asymptote. So the next one, number 3. So what I'm going to do here first is I could do the horizontal first. This has a degree of 2. Degree of 2. So these are the same. So remember, I use the leading coefficients. So this has a 1 and a 1. So my horizontal asymptote is going to be y equals 1 over 1, which is just going to be y equals 1. Now, for the vertical, I need to simplify the fraction first. And the way that I need to simplify this rational function is by factoring. This one's also going to have a whole. So let's go ahead and factor the numerator. Factors of negative 2 that give me positive 1 are going to be x plus 2 and x minus 1. The factors for the denominator of negative 6 that will give me negative 1 are going to be positive 2 and negative 3. Now I look for things to simplify. I can cancel the x plus 2's. And now my simplified function is f of x is equal to x minus 1 over x minus 3. Remember, to find the vertical asymptote, we now take the denominator that it's simplified and set it equal to 0. So my vertical asymptote is at x equals 3. Now, In the homework tonight, you don't have to find any holes, but tomorrow we will. So let me show you how to find the hole that's in this graph. So let me go ahead and I take the factor. So now to find the hole, you're going to take the factor that you canceled. So the factor that canceled, which is the x plus 2, I'm going to set that equal to 0. So I'm going to solve for x. And now I take my newly found value of x, and I have to plug it into this simplified function. So remember, your simplified function was f of x. And remember, f of x is just a fancy way of saying y equals. So I'm taking my simplified function, and now I'm going to replace these x's with what I just found x to be. So I'm going to do negative 2 minus 1, negative 2 minus 3, negative 3 over negative 5. Negative divided by a negative gives me positive 3/5. So my hole is located at the order pair negative 2, comma 3/5. So that is the order pair for the hole. Okay, so for number 4, let's do the horizontal first. So for number 4, we're going to look at the degrees. So for the horizontal, we look at the degree of the numerator. So the numerator degree is 2. The denominator degree is 2. They're the same. So when they have the same degree, remember we use the leading coefficient. So the leading coefficient of the numerator is 3. The leading coefficient of the denominator is 1. So my horizontal asymptote is y equals 3. Now for the vertical, we got to simplify the function first. So I need to factor the numerator. So here is my function, f of x. 3x squared plus 7x minus 6 over x squared plus 4x plus 3. I need to factor these. I know everybody likes to factor by grouping. You could guess and test. So for the numerator, when I factor this, I'm going to multiply, and I get two numbers that multiply to give me negative 18, but who add to give me 7. And that'll be negative 2 and positive 9. So 3x squared minus 2x plus 9x minus 6. I don't care how you factor. Make your groups. GCF here is x. GCF here is 3. Put these two GCFs together, and then the 1 in common. So that's going to be the factored numerator. So now I have f of x is equal to x plus 3 over 3x minus 2. And then the denominator, factors of 3 that give me 4, it's just 1 and 3. So x plus 3, x plus 1. Now I'm going to look for factors that cancel. So I can cancel the x plus 3's. And now for the vertical asymptote, we're going to set the simplified denominator, or simplified fractions denominator, equal to 0. So x plus 1 equals 0. Subtract 1. And my vertical asymptote is negative 1. So far, we've got our horizontal here. We've got our vertical. And now we also have a hole. So remember, for the hole, we take the canceled factor, so the x plus 3, set it equal to 0. x equals -3. And now I take that newly found value of x, and I'm going to plug it in to my simplified function. So now I'm going to plug in -3 in all my x's here. So then I get 3 times -3 minus 2, -3 plus 1. This gives me -9 minus 2 over -2, which gives me -11 over -2. So the y value is going to be positive 11 over 2, or 5.5. So you could leave it a fraction. So my whole will be located at -3, and you could leave it like this. But if you're graphing it, you're going to need to make it a mixed number or a decimal. And again, in the homework tonight, you're not finding wholes, but tomorrow we will. So on the quiz, I would accept the answer any one of these 3 ways. But on the quiz, you'll be graphing, so really you're going to need to make it a mixed number or a decimal. Okay, so for here, remember, in order to find the degree, it needs to be in order from the biggest exponent down to the constant. So really what we need to do is rearrange this first and make it -7x plus 3 over 2x plus 3. All the prior examples, it was already fixed for me. So now I'm going to look at the degrees. So this degree is a 1. This degree is a 1. These are the same. So this is where I have to use the leading coefficient. So for my horizontal asymptote, it's always y equals, and then I use the leading coefficients, and it's going to be -7 over 2. You could make it a decimal if you want, or in this case, you could just leave it. This would be -3.5 or -3.5. I would accept the answer either way. For the vertical, it can't be simplified. I can't cancel the 3's because remember, these are attached. So do not be tempted to do that. You will get it wrong. So for the vertical, what we're going to do is take that denominator, the 2x. You can either use the original or the way you rearranged it. It really doesn't matter. Subtract 3, divide by 2, and your vertical asymptote is x equals -3 over 2, or -1.5, or -1.5. Either way. So no hole, nothing canceled, no slant, because it was the same degree. Let's try number 6. So this one, I can actually simplify. We're going to have a hole here, but let's just do the horizontal. So this has a degree of 1. This has a degree of 2. The top is smaller. So when the top is smaller, your horizontal asymptote is just y equals 0, the x-axis. For the vertical, we need to simplify the function first. So let's simplify. I can factor that denominator. It's the difference of 2 squares. So it's going to factor into x plus 3, x minus 3. The x plus 3's cancel out. And now I'm left with f of x. So f of x is equal to 1 over x minus 3. So now remember to find the vertical asymptote. You set the denominator equal to 0. So x equals positive 3 is the vertical asymptote. And remember, we've got a hole because we canceled that x plus 3. So this one has a hole. So we take that factor that we canceled out, set it equal to 0. X equals negative 3. And again, remember, we're going to take this x equals negative 3, plug it into x, into my simplified function to get the y value. So 1 over negative 3 minus 3. Y equals 1 over negative 6. So my hole is located at the order pair negative 3, negative 1/6. So for number 7, for the horizontal, we look at the degrees. Notice they both have a degree of 2, so the degrees are the same. So remember, we use the leading coefficient. So, and they both have a 1. So 1 over 1, so y equals 1. For the vertical, we need to simplify the function first. So x plus 2, x minus 2 is the numerator factored. And then the denominator, factors of 2 that give me negative 3, that's going to be x minus 1 and x minus 2. So I can cancel the x minus 2's. That's where my hole is going to be located. So my simplified function is x plus 2 over x minus 1. So remember, for your vertical, take your denominator, set it equal to 0, add 1. My vertical asymptote is x equals 1. And then now what we'll do is find the hole. So for the hole, take the factor you canceled. The x of the order pair of the hole is 2. And now take this 2 and plug it into the simplified. So y equals 2 plus 2 over 2 minus 1, 4 over 1. The y of the hole is 4. So the order pair for the hole is 2, 4. So for number 8, I know I wrote all over the place. Let me just rewrite it over here. So for number 8, it's f of x squared plus x minus 2, 2x squared plus 5x plus 2. Notice the degrees for the horizontal, they're the same. So remember, we use the leading coefficient. So y equals 1 over 2. For the vertical, we have to simplify the function first. The numerator factors into x plus 2, x minus 1. The denominator is going to factor. Okay, so we have 2x plus 1, x plus 2. These will cancel. So my simplified function is f of x is equal to x minus 1, 2x plus 1. For the vertical, set the denominator equal to 0. Divide. X equals negative half is the vertical. And then we also have a hole using the factor that was canceled. So subtract the 2. Take this negative 2, plug it in. The hole will be located at the order pair negative 2, positive 1. And then plug in negative 2 times 2 plus 1. This will give me negative 3 over negative 4 plus 1. Negative 3 over negative 3 simplifies to 1. So again, the order pair is the order pair. Negative 2, positive 1 is where the hole will be located in your graph. So again, when you're doing the WebAssign, make sure you separate your asymptotes with a comma. And again, remember, horizontal will be y equals a number, and then vertical will be x equals a number. And sometimes you'll have more than one vertical asymptote, depending on what happens when you factor something.